Alright, so I think this is recording. Let's take a look at these problems. Our inverse sine, we think quadrants 1 and 4. We're going to make x over 1. It doesn't matter whether I claim that theta is in quadrant 1 or theta in quadrant 4. It would be the same answer. So I'm just going to pick quadrant 1. I've got x over 1 is the opposite leg over the hypotenuse. By the Pythagorean theorem, 1 squared minus x squared is the length of the adjacent side. So again, just like in our previous homework, we're letting this inverse sine be theta, and this time cosine theta is the length of the adjacent side divided by the length of the hypotenuse, which is 1. So there's our final answer. Let's take a look here. Inverse cosine is either quadrant 1 or quadrant 2. So let's see what we get if I claim it's in quadrant 1. X over 2, if I go x over 2, and the square root of, by the Pythagorean theorem, 2 squared is 4, minus x squared. So we're letting this be theta. And the tangent of theta is 4 minus x squared over x. I know the principal square root is always positive, and I've assumed that theta being in quadrant 1, that x was positive. Now, is it possible if we said that theta was in, that this x over 2, if this x were a negative value, if we claimed that this theta was in quadrant 2, it would still have the adjacent leg x and the hypotenuse 2, and this would still be 4 minus x squared, and we would get the same answer because we're taking the tangent of theta, which so if theta is in angle, or is in quadrant 2, then we know x will be negative because you're going to the left there, and this numerator is positive, and this, if x is negative, and if you're in quadrant 2, tangent's negative, so there's no problem. There's no there's no contradictions, and we're fine with that being our final answer. So I'm not going to go through that every time. I'm just going to assume that the answers are going to be the same, unless for some reason you would check it and find out that we get two different answers. Alright, so since we have a choice of quadrants 1 or 2, let's just choose quadrant 1. I don't think we'd run into any contradictions. Alright, so if I let theta be in quadrant 1, and the adjacent leg, if I let it be 1 and the hypotenuse be x, this missing side by the Pythagorean theorem would be x squared minus 1 squared, and the sine of theta, the opposite leg, over the hypotenuse, and there's our final answer for that. The inverse tangent, quadrant 1 or quadrant 4, if I've just drawn it in quadrant 1, call that theta in quadrant 1. The opposite leg 6, the adjacent leg, let it be x plus 2. Then the hypotenuse, if I just call this r for a second, by the Pythagorean theorem, it's the square root of x plus 2 squared plus 6 squared, which is 36. I'm just going to leave it in that form. So that's my r. So the cosecant here, let's move this down. The this inverse tangent is our theta. The cosecant is the reciprocal of sine. So it's the hypotenuse. Divided by the length of that opposite side. So there's my final answer. Like I say, in the answer key, we squared it out and simplified it, but I don't see a true advantage of doing that, so I'm just going to leave it in this factored form like this. I apologize if I didn't hit that pause button fast enough. I had to cough. Alright, so let's inverse tangent, either in quadrant 1 or quadrant 4. Let's assume that it's a positive angle measure and that we're in quadrant 1. Let's write x plus 1 over 1 by the Pythagorean theorem. Let's have this r be x plus 1 squared plus 1 squared. I'm just going to leave it like that. The cosine of theta is equal to 1 over that, but I have to rationalize that denominator. Let's shrink this up and give me some room to do that. If we multiply both sides, the numerator and denominator by that radical, then you'll have this in the numerator, and the radical will go away in the denominator. You can't simplify this any further other than squaring it out and combining like terms, but I don't see the true advantage of doing that, so I'm just going to leave it like that. That's my final answer. Arc cosine is just a different notation for inverse cosine. We've seen that. So think quadrants 1 and 2, and I'm just going to put it in quadrant 1. I don't think I'll have any contradictions if somebody had assumed quadrant 2. I'm going to write x as x over 1. So the adjacent over the hypotenuse, and by the Pythagorean theorem, 1 squared minus x squared. So the sine of theta is the opposite leg over the hypotenuse. It seems like we did that one in a previous problem, right? Probably said inverse cos. Probably used that previous notation, but that's my final answer. Inverse tangent. We can assume that we know that theta is either going to be in quadrant 1 or quadrant 4. I'm going to assume it's in quadrant 1. We'll write 4 minus x over 1. So the opposite leg, let it be the length 4 minus x. The adjacent leg, let it be 1. And by the Pythagorean theorem, I've got 1 squared plus this 4 minus x squared. Alright, so the secant of theta is the reciprocal of cosine, so rather than 1 over r, it's r over 1, and we just found r to be this. So I'm just going to leave that as my final answer. Inverse sine, think either quadrant 1 or quadrant 4. I'm going to put it in quadrant 1, the angle, and the x over x plus 1. Since it's sine, the opposite leg, I'm going to let it have the length x. The hypotenuse, x plus 1, so this missing leg is x plus 1 quantity squared minus x squared. Now, I suppose some people might square that out, and then just because the x squareds cancel, but since we've been leaving it alone so far, I'm just going to leave it like that. Alright, so the cosine is the adjacent leg over the hypotenuse. I don't think anything would cancel, but we can check. Alright, so what if I do multiply this out just out of curiosity to see if this would be x squared plus 2x plus 1 minus x squared. And yeah, I can't simplify this radical. 2x plus 1. So even if I had multiplied that all out and get 2x plus 1, I can't really do anything with it. So either one of those, I mean, that's fine. Let's make this 3 over 1. Let's assume that the angle is in quadrant 1, or we could put it in quadrant 4. Let's make this 3x and 1. And by the Pythagorean theorem, if I square that, I get 9x squared plus 1 squared. Take the square root of that, and that's my hypotenuse. So the cosine of theta is the adjacent over that, the length of the adjacent side over the length of the hypotenuse. And if I rationalize that denominator, then I'm getting 9x squared plus 1, the square root of that over 9x squared plus 1. And there's my final answer. Alright. If we assume that theta is in quadrant 1, or we could do it in quadrant 2, and let the adjacent side be 9, the hypotenuse be x. By the Pythagorean theorem, this is x squared minus 9 squared, which is 81. So the sine of theta is this x squared minus 81 divided by x. And that's my final answer. Hey, that's it. So I hope that helps, and I'll talk to you later.